Hello, everyone. Welcome to the June Recreational Astronomy Night Meeting online version of the Toronto Centre RASC. My name is Paul Markov. I'll be your host for this evening, your virtual host, that is. I hope you're doing well and have been able to take advantage of the continuing excellent skies we've had in the recent few weeks. Absolutely amazing weather, and it's new moon too. This is our third Recreational Astronomy Night meeting online, and I'd like to thank in advance our technical team that's comprised of Andrew and Betty Reed, Blake Nancarrow, Ward LeGros, and Ennio Ciolucci. Thank you guys for making these online presentations possible. The speakers for this evening are as follows. We have Arnold Brody presenting the sky this month, followed by Blake Nancarrow. He'll talk to us about building a custom dew heater. And Denis Gray will talk to us about rapid polar alignment. And finally, our president, Chou, will wrap up the online meeting with a few announcements. If you have questions, please enter them in the chat box, which is located at on the right side of the video. And we'll have Ennio read the questions out, and so the speaker can answer them. And if you're attending one of these meetings for the first time, whether you're a member or not, please let us know through the online chat. We'd like to keep track of any new folks participating in our meetings. So without further ado, let's get started with the sky this month, presented by Arnold Brody.
Thank you, Paul, and hi, everyone. For the sky this month, the month is actually the next 4 weeks until we have our next online meeting on July 15th. We'll take a look at some SpaceX news, some upcoming launches, and then we'll get into observing. Now, as everybody probably knows, the SpaceX Dragon Demo 2 carrying veteran astronauts Bob Behnken and Doug Hurley took off from Florida on May 30 and docked with the ISS the next day. The Dragon was the first commercial spacecraft to carry astronauts to the ISS, and the first crewed spaceflight to launch from the US since the shuttles were retired in 2011. Bob and Doug named the capsule Endeavour, in part because they both took their first space flights aboard the retired Space Shuttle Endeavour. The Apollo 15 command module that orbited the moon in 1971 was also named Endeavour. Meanwhile, Boeing has decided to refly its Starliner passenger spacecraft without a crew this fall to dock at the ISS. They tried back in December, but that test failed when the Starliner had trouble reaching orbit. It consumed far too much fuel and didn't have enough to attempt a rendezvous, so they will try again this fall. Here are a couple of great shots by Reza Mohammed and Richard Prentice of Endeavour, the smaller dot or line, and the ISS crossing the sky the night before Endeavour docked with the ISS. 4 days ago, SpaceX launched 58 more Starlink satellites atop of Falcon 9, bringing the total launch so far to 540. The next 60 are scheduled for launch a week today. And SpaceX is developing a rocket called Starship that will launch up to 400 satellites at one time. In total, 12,000 Starlinks are planned for deployment, with another 30,000 possible later on. Starlinks from the first 8 launches are so bright they ruin scientific deep space imaging, as you can see here. Researchers may lose up to half of their images. SpaceX painted a Starlink dark gray to see if that would help. It's too dark to be seen naked eye, but it's still found in images of deep space, so that idea didn't work. So that the Starlinks in last week's launch wore sunshades. All future Starlinks will wear them too. They block all sunlight, so the satellites are then invisible. This might be a new problem for those monitoring stars for dips in magnitude. Basically, we're trading white lines for black lines. And SpaceX is not alone. Others like Web1 and Amazon and China too, they want to fill the sky with their own internet beaming satellites. And I don't know if they're going to be bright or if they're going to be wearing sunshades. I don't know, but low Earth orbit is getting pretty full now. As for upcoming launches, a number have been rescheduled after the interruption caused by the COVID-19 pandemic. Here are the next four, all in June, with launches in China, French Guiana, and 2 in Florida. A number of July launches have yet to be assigned dates, but one launch in July with a date is the United Arab Emirates Mars mission on July 14 with liftoff from Japan. Later in July, there will be launches to Mars, including NASA Perseverance rover and China's Tianwen-1 Mars lander. The Mars launch window opens in July. You can go to Spaceflight now to keep an eye on the launch dates. So I'd like to now turn our attention to observing. The summer solstice is just days away, and the year's nighttime hourglass is squeezed to its narrowest. And those of us near the 40th parallel have only 3 hours and 40 or so minutes of true night on or near solstice. Although the solstice has the shortest night, we can at least look forward to nights growing longer the rest of the year. By July 14, night is 40 minutes longer, but you can observe brighter double stars and planets during twilight. And for Mercury and Venus, you actually have to catch them in twilight. At the solstice, the sun will reach 69 degrees high at local noon, at our latitude of 44 degrees, and Earth reaches its fullest from the sun on July 4, 152 million kilometers away, instead of the typical 150 average. And as of tonight, and all of next week, we have dark skies with the new moon this coming weekend. And then a photogenic first quarter moon with the X and V occurs the following Sunday. The weekend after that, you can watch the full buck moon rising, so named because this time of year, buck deer antlers begin to grow. It's also called the thunder moon or the full hay moon. And then darker skies will eventually return by the end of that week. Throughout the summer, the darkest nights will be mid-month. So now that we know when it will be dark, let's see what's happening with the solar system working our way out from the sun. Active regions associated with solar cycle 25 have been appearing on the sun over the last few months. And magnetogram images by the Solar Dynamics Observatory on the left, they show an active region with cycle 25 polarity. And if this cycle 25 activity continues unabated for 6 months, the NOAA will then say that cycle 24 ended 6 months earlier. In other words, the end of a cycle is determined after the fact. This new activity means the sun has become an interesting daytime target again, with sunspots and prominences returning. Cycle 25 sunspots will appear in solar mid-latitudes initially, like the picture we see here. And they will drift up towards the equatorial region over the next 10 to 11 years, forming what is known as the butterfly diagram, as seen here from the previous 2 solar cycles. Notice that the overlap of spots between the two, that there is an overlap of spots from the 2 cycles, so there is no clear break between them. This renewed activity and with it a likely increase in solar flares, that means we could be seeing more auroras again, like this display captured by Sailu Nemina up at the CAO a couple of years ago. If you'd like to receive aurora alerts in your inbox, visit the NOAA subscription service page and register for the alerts that you want. As you can see here, I'm registered for space weather advisories, which come every week and on any day if something significant occurs. An example of an advisory email is on the right, in which there was nothing happening at the time. I'm sure that's going to change pretty soon. On to the moon. On June 28, we can see or image the lunar X, which is a result of sunlight and shadows on the rims of the Longinus, Lacaille, and Purback craters. The X is visible for a few hours just before first quarter, slightly below the moon's equator. At the same time, a lunar V can be spotted further north up the terminator. It's the result of sunlight and shadows involving Euclid's crater and a few other small ones. In the middle diagram, the yellow dots show where and when the lunar limb is tilted at its maximum towards us due to libration. On July 4, we have a good opportunity to explore the circular Mare Smithy peeking around the moon's eastern limb. And at perigee, the angular size of the moon is almost, not quite, but close to 10 degrees larger than at apogee. Well, there are some interesting moon events over the next 4 weeks, starting in just 2 days. If the pre-dawn sky is clear on Friday, and I think it will be, we can catch a thin crescent moon and a similarly thin crescent Venus rising only 10 arc minutes apart for those of us in the Toronto area. Both can fit within a telescope's low power field or in binoculars. And high magnification of Venus shows its crescent phase imitating the moon, which makes sense since the Sun-Moon observer angle is essentially identical to the Sun-Venus observer angle. So it would make sense they would both have the same phase. Now, if you intend to photograph the pair, please be sure to position an umbrella or other shade to block the nearby rising sun for safety. The moon will actually occult Venus for observers in eastern Canada and north of a line running through Europe and Asia. Here's a close-up showing the occultation zone in eastern Canada, eastern New York, and the New England states. Between these two yellow lines, the moon will rise with Venus behind it, and you can then watch Venus reappear in daylight. Visit the IOTA website for the timings where you live. And now 2 days after that, an annular eclipse sweeps across southern Asia, northern India, and eastern to central Africa on Sunday. The moon's angular size will be just a little bit too small to completely cover the sun, resulting in a ring of fire in the sky. We can expect live streaming of the eclipse. We can check out YouTube for those. And if you catch it, it'll probably be around midnight our time, depending on where exactly along the eclipse path the broadcast originates. On June 29, the moon occults 95 Virginis, magnitude 5.5. It occurs around midnight, depending on your location. The timings shown in this animation are for my home in Whitby, east of Toronto. For those living further west, the occultation happens earlier. And there will be a partial penumbral lunar eclipse on the night of Saturday, July 4 and into Sunday at the times shown here. Now, penumbral eclipses of the moon are very hard to detect. There's not that much darkening. And the previous full moon in June also underwent a partial penumbral eclipse as the moon passed through Earth's northern penumbral shadow. In between these two near misses of the Earth's umbra, the new moon of June 21 crosses the ecliptic right on the node on the opposite side of the sky, of course, producing the annular eclipse we just talked about. On to the planets. Looking down from above the sun's north pole, we see the relative positions of the inner four planets as of tonight. If we treat this white line as the horizon for our stargazers, the sun is about to rise. They can see Mars up fairly high, so it must have been up for hours, and Venus appears very close to the horizon, having just risen before the sun does. It's now about an hour later, and stargazers on the other side of Earth have just watched the sun set, and for them, Mercury is visible low in the west, about to set soon itself. And here are the inner planets on July 14. Mercury has traveled about a third of its orbit to the other side of the sun from our perspective. Now all three inner solar system planets are visible during some part of the night or pre-dawn. Let's take a closer look. As we just saw, Mercury is visible very low in the west after sunset tonight. Its orbit is taking Mercury to inferior conjunction. It will pass between us and the Sun on June 30. Now, if you have an unobstructed or elevated view to the west, you can pick out the magnitude 2.2 speck of light in binoculars after sunset the next couple of days. But do wait for the sun to set before trying, of course. By this time next month, Mercury has swung to the other side of the sun from our point of view and is now rising in the pre-dawn spot than it was back on June 17 because it is slightly higher on this date and hence further from the sun and around twice as bright. As we just saw, whoops, I went the wrong way, sorry. Venus just finished a great show as the evening star this past winter and spring, and now it's west of the sun, what we call the morning star, and for the next 4 weeks, it will be climbing higher. Tomorrow morning, Venus will be just 6% illuminated, but a brilliant magnitude negative 4.3 because it's relatively close to us, giving us a larger surface area. It's almost a full arc minute in size, over 50 arc seconds. By July 14, Venus has come close to the anse of its orbit, which it will reach on August 12, and has dropped in angular size to about half an arc minute, though slightly brighter at minus 4.5. This would be a good time to try taking an image of the thin crescent, especially when our atmosphere is calm before dawn. With luck, you might capture the crescent Venus like Rick Foster did on May 13, when it was still east of the sun. This image is all the more impressive when you consider the turbulent air close to the horizon that Rick had to deal with. Well done. Now, on to Mars. In mid-June, Mars rises around 1:30 in the morning, climbing to around 30 degrees high in the southeast by the end of astronomical twilight, which occurs around 4 a.m. In the pre-dawn, the air is typically very calm, having had all night to settle down, providing good seeing needed for planetary detail. And being 30 degrees up, Mars is above much of the obscuring atmosphere, improving our chances of seeing it hold steady. Now, the amount of atmosphere we look through depends on the altitude of the object we're viewing. With Mars 30 degrees up, we're looking through two air masses, about 1/3 less than when just 20 degrees up. That's why it's so important for planets to rise above 20 degrees to get an opportunity for a decent look. We are at the start of the great apparition of Mars for 2020, and we will come very close to Mars at its opposition in October. Over the next 4 weeks, Mars drifts 1 hour of right ascension from Aquarius to Cetus. And as of the 14th of July, Mars will be 13 arc seconds wide, getting brighter now at negative 0.7 magnitude and 85% illuminated. These are photos of Mars taken by fellow club members during the last approach in opposition of Mars in 2018. They have been posted on our forum astrophotography section where you can read more about them. As for observing Mars, you will want to use as much magnification as your telescope and local conditions will allow. Now, rule of thumb is a telescope can theoretically achieve 50 times magnification per inch of aperture. So if you have a 4-inch scope, you can push it to 200x. If you have an 8-inch, you could push it to 400x. And you may try using an eyepiece that achieves your maximum theoretical magnification for your scope because Mars will be up high in the pre-dawn sky when the air should be steady. And so give it a try, and if it is steady, you'll get some great views. Otherwise, you may have to back off to a lower power eyepiece. And using color filters can enhance certain features. Orange increases contrast between light and dark features, and that will also penetrate hazes and most clouds. Yellow brightens desert regions and darkens bluish and brownish features. Red enhances fine details on the surface by darkening the non-red areas, and light green enhances frost patches and polar caps. Finally, blue filters may show you clouds and limb haze. So if you have these color filters or decide to get them to maximize your viewing of Mars this summer, remember you can also use them for viewing Jupiter and Saturn as well. Mars passed through its equinox in April, autumn for the north, spring for the south. Its southern hemisphere is tipping towards the sun and us now. Maximum tilt, the start of summer for southern Mars, occurs on September the 2nd. So as we observe Mars this year, we will be watching its south polar cap shrink. On our way to the gas giants of the outer solar system, we pass through the asteroid belt where 5 of the brightest are approaching opposition, namely Alette, Antigone, Lydia, Herculina, and Palais. And here are the paths they will take across our sky the next 4 weeks. The location, date, and magnitude at opposition are marked for each of the asteroids. I think the brightest one is Herculina. It reaches 9.5. And here's an example of how far Herculina travels at opposition. The field of view here is about 1/2 a degree. And if both of those nights are clear, and if you take images of that area, you could try your own blink test to find the asteroid leader. Now we've reached the outer solar system, and here are the positions of the gas giants as of tonight, and 2 dots next to the sun, showing Earth's position tonight and on July 14. Here's a horizon line like we used earlier with the inner solar system. For those on the night side of Earth, all 4 outer planets are visible, at least for some portion of the night. And here's another line representing the location, I should say the horizon, for people watching the sunset in their western sky on July 14. If they turn around and look east, they will see Jupiter rising. In other words, Jupiter will be rising at opposition that night, rising as the sun sets, with Saturn to follow a week later. Jupiter rises at 10:47 tonight, so after the show, you can get outside and take a peek. And it will cross the meridian 6.5 hours later at 3:17 in the morning when the sun is still 17 degrees below the horizon, so still quite dark. At that hour, our sky should be calm, having settled down all night, and that should give us good seeing so we can pick out details in Jupiter's cloud bands or capture excellent photos like the one here by Rick Foster. As for colored filters, a rule of thumb is to choose a filter with a color opposite that of the feature you want to see. So to enhance the great red spot and the reddish-brown equatorial bands, you can try a blue filter. Blue filters block some of the red, darkening the red spot and equatorial bands so they stand out in greater detail. In larger telescope, or in greater contrast, I meant to say. In larger telescopes, a red filter can bring out projections and festoons along the edge of the equatorial belts, and a light yellow filter may enhance the polar regions. It takes Jupiter 10 hours to rotate, so there's an opportunity to observe or time-lapse record its rotation at or near opposition. But being summertime, we only have a few hours of night, so we can only catch part of that rotation. Shadow transit across Jupiter by its large Galilean moons are fun to observe, even image. Here's a depiction of how the transit of Io and its shadow will appear at 1 a.m. Eastern Time on June 30. Cal Sky predicts the great red spot will transit that morning at 2 a.m. So I doctored this image to place the GRS where it should be at 1 a.m. Jupiter will be 22 degrees up then, so we're going to need some good seeing for a decent view or astrophoto. And here's Jupiter's retrograde path as Earth overtakes it in our race around the sun. The upper left oval shows where Jupiter is tonight. The one in the center is where it will be at opposition, and it's interesting to note that when at opposition, it is halfway between the extremes of its retrograde path. And here's a special bonus for anyone with a 10-inch or larger telescope, a chance to spot Pluto with Jupiter's help. Jupiter and Pluto had 3 conjunctions this year due to Jupiter's retrograde motion. The second of the 3 occurs on the night of Monday, June 29, and on through midnight when both planets are at right ascension, 19 hours and 44 minutes, shown here. The declination lines in the grid are 10 arc seconds apart. So if you have a 10-inch or larger telescope on an equatorial mount without GO2, you can try spotting Pluto, which reflects sunlight at a feeble magnitude, 14.3. First, center Jupiter in a high-power eyepiece, then slew south 40 arc seconds. Pluto is now in your field of view, but it will be low, and it will be faint. So I wish you good luck in finding it. On to Saturn. Saturn rises tonight at 11:04, just 17 minutes behind Jupiter, and crosses the meridian 17 minutes behind Jupiter as well, around 3:44, with the sun still very low. So it will be a good opportunity, again, with steady air that we should have in the early morning hours, and it will give us sharp views of the planet and its rings. And maybe you'd like to give sketching a try. The rings are tilted around 21 degrees to our line of sight, nearly hiding the southern pole. This summer and fall, the tilt increases another 1.5 degrees, almost completely hiding the southern limb. And the diameter of the outer A ring is 2.6 times that of Saturn itself. So when Saturn reaches its greatest angular size of 18 arc seconds around opposition, the rings will extend 43 arc seconds, almost as wide as Jupiter at 45. And here is Saturn's path in the sky. It's also going through retrograde now. And the portion of Jupiter's path that is in this image, I colored it blue to be less confusing. And here we see the position and appearances of Uranus and Neptune on July through my reporting period. These planets rise in the morning, Neptune around 1:15 and Uranus at 3 a.m. That's the beginning of astronomical twilight, and neither planet reaches the meridian during nighttime, so this is not a good time to see it. Neptune reaches opposition in September, and Uranus a month later, so late summer and early fall will be the prime time for viewing these little blue dots. Moving on to comets. Of the 8 brightest comets listed in the skylive.com, only 2 are up during the night in the northern hemisphere at this time, C 2017 T2 and C 2019 Y1. The other 6 are currently visible from the southern hemisphere, and some will cross the ecliptic and become visible in the north. I suggest you visit the skylive.com/comets if you want to stay current on these bright comets and find out when some of those may be crossing the sky coming north. The 2 comets that we see here are fading. A large aperture, moderate to large aperture telescope would help. Of the 2, the Pan-STARRS is still fairly bright at 9.0, so you may be able to catch that without too much trouble. There are no meteor showers at this time. The next one is the Southern Delta Aquarids in late July. And on to deep space. Here's our sky 4 nights from now on the new moon Sunday at 11:30, the true start of night. Now, this would be your last weekend for targeting the galaxies in the Virgo, Leo, Coma Berenices area until next spring. And west of the meridian are a handful of globular clusters. Messiers 5, 3, and 53 are all high up, providing excellent views. Even higher are globular clusters M13 and M92 as they pass overhead, touching the zenith or nearly so, giving you a chance to observe or photograph these dense balls of stars through only one air mass. Like Chou did when taking this detailed image of M13 up at our Chou Observatory last June. And here's the sky looking south on the night of July 14-15, when Sagittarius and the Milky Way's nucleus cross the meridian at the start of night. The Sagittarius arm of the Milky Way, you can see it rising here from the nucleus, is stretching overhead up through Cygnus the Swan and on to Cassiopeia. This is prime time for the globular clusters that form a halo around the Milky Way's nucleus, and treasures of all kinds that are embedded along the Milky Way, such as planetary nebula like M27, the Dumbbell Nebula found in Vulpecula, emission and reflection nebulae like the Lagoon Nebula, 6 degrees north of the spout of the teapot, and the Trifid Nebula, 1.2 degrees further north, or open clusters like M29 and Cygnus, or double stars like colorful Albireo, or the challenging double-double Epsilon Lyrae that are barely separated here in this photo. You will have actually a good opportunity to try splitting the double-double because they are passing very close to the zenith this month. And so you're looking through, again, just one air mass to try and split them. And I think it's a bit ironic that all of this wealth of deep sky objects are up during the shortest nights of the year. But at least it's not frigidly cold. As you wage your battle with biting insects while trying to enjoy the stars this summer, you might want to be on the lookout for bugs in space. I have 4 for you, starting with Caldwell 19, the Cocoon Nebula, an emission nebula surrounding newborn stars. Found in Cygnus, flying high in the east, magnitude 7.2 and 20 arc minutes wide. Not quite as big as the full moon. It's 2,500 light years away. The second is a very faint and it may be difficult to find. It's NGC 6537, the Red Spider Nebula, although spiders are arachnids, not insects, I know. But found in Sagittarius, it is magnitude 13. So that's going to need a large telescope to see optically. It's probably best captured by camera. A companion star, or maybe it's magnetic field lines that are forcing the expanding nebula to take on that two-lobed shape. The third is the Bug Nebula in Scorpius, also known as NGC 6302. It's sometimes called the Butterfly Nebula, but I'm saving that name for the next slide. It's a bipolar planetary nebula. It may be a challenge due to its low declination. For us, it only reaches about 7 degrees high at best. An elevated viewing location will help. Aim your telescope 4 degrees west of Lambda Scorpii, the scorpion stinger. The bug will look like a slender, fuzzy streak in a 150 millimeter telescope and more like an hourglass in scopes 200 millimeters and up. The second, I'm sorry, I did that again. I'm sorry. The final bug in space is the Butterfly Nebula embedded in IC 1318. Also known as the Satyr region in Cygnus. It rides very high in the sky this summer. There is at least one other butterfly nebula, NGC 2346, but that is currently lost in the sun's glare in Monoceros. IC 1318 lies 850 light years away and glows weakly at magnitude 14.9. This is definitely an astro imaging challenge. Well executed in this image of the Seder region by Adrian Aberdeen. I would like to thank our club members listed here on the left for their astro photos. They are excellent. And that's a wrap, Paul. Enio, are there any questions?
So, we have one question from Eric Briggs. Is Arnold using Starry Night? There's a text file in Starry Night that can be used to update the Great Red Spot positions to keep it current.
Yes, as you see on the right, I was using Starry Night Pro, both 6 and 8, Stellarium, and Virtual Moon Atlas to help with the images in the show. Thank you for the tip on updating, and I'll try that to see if it works.
And while the question was answered in the chat, Ashita Parek is asking, is it possible to see the Milky Way this month from the Long Sault area near Toronto?
I think so. I have seen it from Long Sault. I've also seen it on a very good night from Glen Major Forest. So I think if you get out, and if it's a dry night with no haze, that would help a lot. Then yes, I believe you will be able to see it.
And Eric adds to his question, the file is called jupitergrs.txt.
Thank you.
Okay. Any more questions, Enio?
That's it for now.
That's it. All right, perfect. So thank you very much, Arnold, for a very thorough presentation. Well done, and I appreciate you taking the time to prepare for this and sharing it with us. Thank you so much.
Well, thank you too.
All right. I think we're ready to move on to our next speaker, but first we need a quick break to set up. We'll be right back. All right, and we're back. Our next speaker is Blake Nancarrow. He'll talk to us about building a custom dew heater for your telescope lens.
Thank you, Paul. My name is Blake, and it's my objective to share with you how to build a dew heating strap. If you want to do astronomy in Canada, you need dew heaters. If you want to do astronomy for a protracted period of time, you want to do visual or photographic work, you need dew heaters. Some people think you only need dew heaters in the summer. No, you need them all year round. Anytime you have high humidity, that's going to be an issue. Amazingly, from my backyard, I haven't had to run the dew heaters for the last 3 or 4 nights, just because the daytime humidity is low and the temperature is not falling terribly low. But if you have the temperature dropping low and you're getting close to, at, or below the dew point, then you're going to need dew heaters. And let me say right away, I just want to apologize in advance to Mr. Jim Kendrick. I need to make some disclaimers here. I'm assuming you know which end of a soldering iron to hold. And if you do undertake some of the things that I'm suggesting, that you're not going to sue us if you burn up your telescope or your workroom. I do want to caution you, there are some risks here. If you don't do your math right, you could have a heating element that goes red hot or white hot, and that could burn stuff, set things on fire. You could burn yourself. There's a possibility. I think the risk is a bit low, assuming that there's fuses in place, but you might damage your controller for your dew heating system. So be careful here, and I'll emphasize later when you're doing the math, do some double checking and testing and so on. But and if you don't know what you're doing, I hope you'll ask if you're not confident. People will help on our forums. There's at the end of this presentation, I've got some contact information. You can reach out to me, and I'll try to answer your questions for you. So here we go. Why do you want to do this? I have 2-inch dew heaters from Kendrick Astronomy based in Toronto. I've had several of them, in fact, and I've gone through a number of them. They have broken or failed. In general, I think the build quality of these products is good, but I wonder if they're just not robust for how a lot of us use them. If you have a permanent observatory and you're putting dew heaters on the telescope and they stay there for months or years, great. There shouldn't ever be any problem with those. But I think about when I'm doing observing and I take the 2-inch heater off of one eyepiece, put it on another one, and then change eyepieces again. So I take the dew heater off and put it on another one. Even though I'm trying to be careful, I'm trying to be gentle with it, I'm trying not to bend it or crimp it or things like that. And when I store it in the case, I coil it up very gently. I make sure it's not being pinched or compressed or anything. And I'm trying to be really careful, but they keep breaking on me. And I think inside them, there's some very fine wires that are maybe brittle or just can fail over time if they're bent the wrong way. So that was sort of part of the issue for me, that I recently ran into a problem again with one of my dew heaters. In fact, it was on an observing session about 18 months ago in the backyard. It was cold. That's not my telescope, but I had very cold conditions, and there was some frost on the telescope, and the eyepiece kept fogging up. And I had the dew heater wrapped around it, and I thought it was working okay. And I took my hand out of my glove. My hand was cold, and I felt the dew heater, and it kind of felt like it was working. It wasn't ice cold, but it didn't feel really warm either. So to make a long story short, I tested it, and I found it was intermediate. It worked in a certain position and not in others. So I knew there was a bad heating wire or nichrome wire inside it. So, and again, this is not the first time this has happened to me. So I was frustrated, and I needed a solution. But I have some talent. I had almost all of the supplies that I thought I would need. In fact, I've been collecting for years nichrome wire from various sources. I'll talk about that in a bit, where you can find nichrome wire, and over the years I've looked at various designs that I've found on the internet, and sort of bookmarked a few of those, kept track of them. But I was greatly inspired by a particular design by an amateur astronomer who lives in the Philippines. I went looking for his website recently, and I think he redid his blog or redid his website, so I couldn't find a bunch of things now. I couldn't find his article in particular, so I don't have a link for it. But at the time, I took the pictures. I thought it was really interesting, his design. So do you see what's going on here in this top image? That there's this plastic thing that forms kind of the core of the heater, and he explained that he got that plastic from just a file folder. He'd gone to a stationery store, he bought a file folder, plastic type. You can see it's sort of clear, translucent, and he just cut it into a strip. So I thought, hey, that's a good idea. Plastic core, that'll work nicely as long as it stands up to the heat. So that's good. And you can see that there's wire wrapped around it in this zigzag pattern. If you look closely, that's heating element wire and nichrome wire. And his wire is pretty fine there. And if I remember correctly, nichrome wire is brittle. So you don't want to bend it back and forth a lot. It might snap. Anyway, I like that design. But what I didn't like is all the electrical tape that he put on it. Here, I thought, after a while, I know that stuff gets sticky and gooey and maybe starts to move around or slide a little bit. So, but the reason he did that is he wanted to sort of to get the wires locked down. You don't want those moving around because you could get a short circuit and that could change the heating output for this. So I was a little bit nervous about that if I was going to mimic this. I came up with an idea for sort of getting around that. So here's what I did. I took a plastic piece, clear sort of light blue plastic, and do you see the notches that are in here? I put notches every little while, and that's meant to hold the wire in place without using big blobs of electrical tape all over the place. So that was just an idea that popped into my head, this sawtooth kind of design. And I even thought of another way to do that. You could have a hole and a slit in the plastic to kind of capture the wire in place. There'd be no way that it could move then. The wire that I've put around this is under some tension, so I do not think that the wires are going to hop out of their grooves at all. So I'm not worried about short circuits with this. So I was quite pleased with this sort of approach or this design. And Denis' design, again, I found very inspiring because I thought it's a really flexible system. And I don't know if you can make out the wire that I'm using here, but it's kind of crimped. It's a kind of a wavy line. And I'll explain why shortly, why it looks that way. But I know that this wire is really, really flexible. So I'm not worried about it breaking. It's quite heavy, robust wire. So I'm sort of happy with this approach. My friend Rhonda gave me a great idea for the plastic core, and in a moment of inspiration, I realized that I had something that I could use to make a casing that would provide insulation. Obviously, you don't want these metal wires touching any metal on your telescope. They have to be protected or insulated. So now the math part. Sorry if you don't like doing this bit, but if you do want to build your own dew heater, there's a few things that you need to know. You're going to need to perform. So you need to know your heat target, how much power you're trying to produce or output. You need to have a pretty good idea how long the heating element or nichrome wire needs to be, and you need to know the resistance of that wire and sort of take all those things together. So I looked at a bunch of dew heaters that are out there that are small for 2-inch eyepieces or 3-inch eyepieces or camera lenses, and looked at some of the different vendors that make them. And I found that they were producing anywhere from 3.5 to 10 watts. So that was sort of a target for me. Now you need to know your electronic theory forums, formula here. So the voltage is squared and the P is the power, your heat target, and that'll tell you the resistance that you need. And of course, I'm driving all of this, the classic sort of thing with telescope accessories off of 12 volts. So 12 volts squared over the power rating. I just kind of chose a number in between. I thought, hey, I'm going to go with 9 watts. So that means that the target resistance that I needed, 16 ohms. Now you got to be careful with this because you've got a power calculation here and you're doing division. So small changes in some of these numbers can make for big changes in other ones. So again, you want to be careful here when you're doing the math so that you don't light anything on fire that you don't intend to. Then I needed to figure out the length of wire that I needed. You saw that plastic piece that I made, and I had the sawtooth in it, and I put those notches in the plastic every 15 millimeters. I just randomly decided on that, and then that produced this zigzag pattern for the wire, and I counted the diagonals and the verticals. I had 16 of each. So that meant as I wrapped the wire around, I needed a total run length of 85 centimeters of wire. So now I had another important number. I had the ohm rating, I had the amount of wire that I needed, and then I went to my supply. I had a lot of resistive heating wire, and some of it was rated at 44 ohms per meter, and some of it was down to 7.3 ohms per meter. I chose a piece of wire that was 25.8 ohms per meter, and of course I needed 85 centimeters of that, so 85% of that gave me an ohm rating of 22 ohms. I bench tested that before sort of building the whole thing, and put it on my controller and hooked it up to the battery and turned it on full power, and it was good. I was able to hold the heater, didn't burn my fingers. I didn't set my desk on fire. There was no new supernova in our solar system that couldn't be explained. So it was a good sort of test. So I knew my math was all good. So I had sort of everything that I needed in terms of the resistive wire. Again, Rhonda gave me the idea for the plastic core. That was like fantastic. I was explaining the project and see I needed some plastic, and I was thinking that I would go down to the dollar store and buy a few plastic file folders, and she said, here. And she handed me a empty bottle of sparkling water, this light blue sort of color. It was a really nice size. I knew it would fit a fairly large eyepiece. I don't know if any of you have those Teleview eyepiece hand grenades, huge eyepieces, but I have some modest size 2-inch eyepieces, so it would work well for that. I've got some camera lenses that maybe have 7, 8, 9 centimeter diameters. So I needed something that would work in all of those kinds of different applications. But this bottle was perfect, so I just cut a slice of that out, 2.5 centimeters wide, and a neat thing about it is it was pre-curved. It was in the shape or the sort of the pattern that I wanted. So I was really, really happy about that, and free. So that was good. It was headed for the recycle bin. I have done this for many years, nothing terribly lately, but I harvested a lot of toasters, and I took the heating or the resistive wire out of the toasters. That's where that crimped wire came from that you saw in my earlier photo. So if you've got an old toaster, it's dead, you can use that. I don't need my hair dryer anymore, so I took the heating elements out of those. A lot of hair dryers have coiled resistive wire, so that won't necessarily work for a dew heater application, but you might be able to use it for other projects. And of course, you can buy this stuff from electronic shops. I bought some somewhere, and I've totally forgotten where I got it, but I got a good sort of length, and it was about $2 per meter. And if you buy it from a store or you buy it online, you can pick the resistive power rating or resistance that you want. So I started putting stuff together. Again, there's a snapshot of the plastic core. I've got my tape measure to hold it down because it wants to curl up into the original circle. It's got the memory in the plastic. I wrap the toaster heater wire around it. And then another sort of moment of inspiration kind of thing that happened for the project is I realized that when I was out at the shed looking at a flat tire on my bicycle, that a bicycle tube would maybe be the perfect size. And of course, offer very good insulation. I have two bikes. I have a racer that's got tires that are less than 1 inch, but the mountain bike tire or tube size, 1 3/8 of an inch tire size was great. That was a really good size and fit around the plastic, forming this very good sheath and offered a bit of structural stability to this as well. So that was good. You need to get power to the heater, so I wanted a cord that was pretty flexible. Years ago, I was at Active Surplus down on Queen Street, the orange store with the gorilla, and I bought a long length of speaker cable, and I can't remember if it's 2 conductor or 4 conductor, but it's got this great jacket on it. It's really nice soft rubber. It's very flexible and cold. So obviously you need 2 conductor wire to get the power up to the heater. I've found with the stock or commercial dew heaters, the power cords are a little bit short. Sometimes they're not quite long enough, or there's the danger of stressing or snagging a cable. So I deliberately made the power cable a little bit longer, about 1.5 meters. You could use lamp cord. You could use speaker wire. That would be fine. You just need to make sure it's a good gauge. You don't want to use really fine, thin wire. You want to use a large gauge because you don't want any heat produced in the wire. You just want to transfer all that power as effectively as possible. All this stuff, I had all this in my part bins. So I actually didn't have to go out and buy anything to make this this dew heater, including the little bits and bobs. If you're plugging into a standard dew heater controller, you need an RCA connector, RCA jack, an RCA plug to do that. And then there's various supplies, electrical tape and stuff. Another little thing that I did is I put aluminum foil inside the dew heater so that it forms a reflector. It's on the back or the outside edge. So I'm just trying to keep a little bit of energy directed back towards the eyepiece. And I made a fabric cover for that. So there's a few dollars there. Maybe if you had to go out and buy all these parts, maybe, I don't know, $15, $20 you're looking at all told. Again, for me, I had everything. So I didn't sort of spend a dime. It was just my time. You need some tools here, of course, for this. I used various tools that I've noted here. Again, hopefully it's clear. You want to be careful about the math. So you need an ohm meter or a digital multimeter. You can do an additional check and use an amperage meter as well. Make sure it's at the proper power rating, because you might be producing 7, 8, 9, 10 amps of power. That's a lot. So you want to be careful. And I sparked up the sewing machine at the end to make the cover for this. And there it is, all done. You can see I've got the fabric cover in. Immediately below the fabric cover is the bicycle inner tube. That's around the plastic sheath. The plastic core has the wire around it. On the outer surface of the bicycle tube, there's a piece of aluminum foil, again acting as a reflector. There's my microphone cable and an RCA plug. And if you're wondering what the white thing is here, that's just a twist tie. When you buy the commercial dew heaters, they usually have an elastic band and Velcro or hook and loop that's being used to enclose it or lock it in place. I thought about that, but I decided not to go that route. All the times that I've used this dew heater to date, I've just snapped an elastic band around it, and that's been fine. But I found a really long twist tie, so that will work as well. So lots of things here. The final, it's all but done. The final thing that I need to do is just hand sew just in this area. And I'm going to put a few threads through the plastic or the rubber sheath there of the power cable just to lock everything in place. But it's done. It works really well. I'm really happy with it. And again, for me, it didn't cost anything. So if you're not a do-it-yourselfer, if you're nervous about any of these steps, if the math is unclear to you, I strongly recommend visiting our local Toronto astronomy accessory vendor, Kendrick Astro Instruments, and the 2-inch heater is around $71 Canadian. I looked at the website just recently, so those are the prices as of now. Kendrick used to make kind of an economy series called the Firefly heaters, but I don't see those on the website anymore. So I think those are discontinued. And you can see by the website snapshot that they've actually dropped the prices for the premier heaters. So they're a bit less expensive than they used to be. So again, apologies to Jim Kendrick. I'm not trying to undercut anybody, but for me, I'm doing multitasking. I've got my Kendrick 8-inch dew heater for my big telescope. I've got the Kendrick controller that drives that. I used to have a Kendrick 2-inch eyepiece. That's dead, doesn't work anymore. So I've made my own. And if I want to run my camera at the same time, I need another dew heater. So I'm going to build a couple of these to use for my eyepiece and my camera lens. If you have an imaging rig, you need a heater for your objective or for your secondary mirror. You need one for your guide scope, maybe one for your finder as well. So invariably we need 2, 3, 4 heaters maybe. If you're really serious about this and you want heaters for your binoculars, you need 4 right there for the binoculars. So it's kind of amazing when you start to add it all up, how many that you need. I've made all the information about my build, detailed information available on my website. I list all the supplies and parts and consumables in detail, and I explain all the steps. And I have links to my specific blog site, blog articles that have photos and detailed information there. So it's kind of an online how-to guide. If you use that website URL, that'll take you to the article with all the detailed build information. If you have a QR code reader on your phone, you can scan that code. It will take you to that article. Again, apologies to Jim. He's a nice guy. He's helped me out a lot. But if you're on a budget, if you need lots of dew heaters, if your current dew heater has broken or failed, or you need more to do multitasking, and you are good with a soldering iron and you've got some of these electronic bits around, then you might be able to make some pretty easily. So thanks for your time. I don't know. I have no idea how much time I took. So, but if we have time for questions now, I'm happy to take those. I've got my email address there, so if you have a follow-up question after, I'm happy to do that. I hope that you can keep your telescope nice and warm, but not too hot, and that will help you observe all night long or image all night long. Thanks.
Thank you, Blake. Let's go to some questions. Ennio, do we have any?
So we have a comment from Eric, who writes, protection of dew is important, but a heater, in my humble opinion, is not your first line of defense. A dew cap uses no electricity, has no wires, and baffles straight light. That's the thing. Reduces reliance on heater.
Yeah. I have a dew shield, and my finder scope has an integrated shield, and when you use a Newtonian telescope, you kind of have built-in shielding for the primary mirror. And if you have a camera lens with a hood, an extendable hood, that all that helps. And there's a rule of thumb: when you have a dew shield, that it should be at least 1.5 times the diameter of the telescope tube. So if you have an 8-inch telescope and you put a dew shield on it, the dew shield should extend out 12 inches, right, or more. I put a foam wraps around a telescope to serve as dew shields. I've used cardboard, thin cardboard to wrap around a telescope, snap an elastic band on it, acts as a dew shield. So that's great. And again, no muss and fuss in terms of electricity or power. But there have been many a time where even when I've done that, I've been wiped out after a couple of hours. A place that comes to mind is just about every time that I went to Mew Lake in Algonquin and we observed beside the beach. Of course, then we're asking for trouble. But every time that I was at the park observing in September, people were getting dewed out, and I needed my shield and my dew heaters, and I had the dew heaters running at full blast. And the shields that we're talking about are a great idea and may keep the dew at bay, but that's only working at the front of the telescope. So my whole thing here was about an eyepiece heater where, you know, if that's exposed for any sort of amount of time to a humid, say, summer evening, it's going to dew up. And I've found in the wintertime that eyepieces get so cold that the heat and moisture from my eye and my face make the eyepiece fog up. And I can't stand that when there's fog on the eyepiece. That's just drives me crazy. So I think with respect that in extremely high humidity situations, when you're very near or at the dew point, a dew cap will only do so much, and putting covers on an eyepiece or covers on the finder are going to help, but that's only a partial solution. You're going to need active dew heating, I think, in extreme scenarios.
The first question is, could you use peel and stick foil duct tape? And the second question is, should you build a heated eyepiece case?
So those are good questions. When I was thinking about the foil, the reflective foil, which I actually put inside my custom heater, I did think about aluminum duct tape with the sticky backing on it. So that's an alternative, and I think that would work fine. The way I built it is the reflector where I put the foil was on the outside of the outer perimeter of the heater, and if I used aluminum sticky tape, then the sticky bit is sticking out there. So if you just accommodated for that in your design, that sounds fine to me. I think that would work. So that was on my list of supplies when I was thinking about building this. Do I use aluminum foil or do I use aluminum duct tape? And I went with foil. Yeah, that's a great idea. One of these days I'll build one of those. What I sort of do, I have my eyepiece case, and if I'm out in the open somewhere, I make a point of closing the lid. I know lots of people, they set up all their gear, and many a time I see eyepiece cases sitting open in a high humidity situation, and I think you're asking for trouble there. I close the lid, I have a towel in there, and so on. Now, one day when I was in an electronic shop, I found a sheet, some sort of heating element sheet. I don't know what it's used for. It was just this raw sheet, and and it was about 12 inches by 12 inches, wires coming off of it. I hooked it up to 12 volts. It got warm. So I thought, I went, this is great. I bought 2 of them, and I've never ever used it for anything. But that would be maybe a nice thing to build into a case, or maybe just slip inside the cover. And it's got plastic coating on it. It's all sort of insulated, so that would keep the eyepieces warm. So that's sort of a neat idea. Heating right inside the eyepiece case, or having some sort of active element inside the case would be good. But in lieu of that, if you're observing, don't leave your eyepiece case open. As Eric suggests, put all your caps and covers on your eyepieces when you're not using them. Many a time I see people observing and they take one eyepiece out of the telescope, put it on the table, switch to another eyepiece, and it's out in the open. So that eyepiece will get dewed up just sitting there. If nothing else, you just need to cover it with something. So it's not sort of out in the sky in the open air.
No more questions in the chat.
Questions? Okay.
Okay, thanks for your time.
So, Blake, to this day, I still don't have a dew heater for my eyepieces. And just a very quick story. A few years ago, I was observing at Starfest late August with a Dobsonian telescope. And as you mentioned, you typically don't need dew prevention on a Dob. And sure enough, my eyepiece dewed up pretty badly. And I thought I was out of business. I was done because I didn't have a source of heat to defog the eyepieces. But then it occurred to me that I was running a laptop. So I used the laptop's exhaust to slowly defog the eyepiece. Yeah. And that worked just fine. So I kept going.
we do what we got to do. So Starfest, for people that don't know, big star party that happens near Mount Forest in Ontario, and typically in July or August. So prime time sort of weather conditions where it's really hot in the day and then it cools off dramatically in the evening. And invariably the temperatures get very close to the dew point every evening. I look at that when I am planning an observing session. What's the temperature now, sort of in the early evening? What's the humidity right now? What's the predicted dew point? Good astronomy websites, weather websites like Astrospheric, show you the dew point and how close the ambient air temperature is getting to that. And if you're within 2 or 3 degrees of the dew point, dew is going to start to form. It doesn't happen only at the dew point. Dew is starting to form before that. And by the time you're at 95% humidity, if you don't have any sort of heating or a hair dryer or some warm pockets, you could be done. When I started observing, that the store didn't tell me about this. I'd blow my budget anyway, but the store didn't tell me when I bought my telescope, you think about dew heating. So I just assumed, because I was on my own, didn't talk to anybody, I just assumed that if you did astronomy, you could only do it for an hour, and then you'd pack up and go home. So that's what I did for the first couple of years. And then I started thinking, there's got to be, go for a longer period, longer observing sessions here. And I started learning about passive and active dew strategies. So I got the dew cap. That was the first thing that I got. And that only helped to a degree. And then I started getting dew heaters. And that was night and day. That it just made the whole evening available. So hopefully this has given you some ideas.
Very good. Thank you so much, Blake.
Welcome.
Excellent presentation, as always. So our next speaker is Denis Gray. He'll talk to us about rapid polar alignment with Sharpcap, but please give us a moment to get him set up and we'll be right back. We're back, and Denis Gray is ready to go to tell us about Sharpcap.
Great, thank you very much, Paul, and welcome to my little interesting presentation. This presentation is kind of an example of a stumble upon kind of presentation where I found this feature and wasn't really expecting to find it. I'll explain a little bit behind that story, but I was excited, and it makes a good presentation, and I think it's kind of a unique take on an old problem that I think we all share. So just in terms of what we're going to talk about, I'll talk about what is Sharpcap, where does it fit in the pantheon of imaging software out there. I'll show them a little bit about my particular polar alignment challenge when I'm observing from my backyard in my deck in downtown Toronto. And then I'll we'll show a video and annotate and talk about that, and I'll go through the polar alignment process. Should take about half an hour or so. I'm sure that'll be fine. And cover off some key points, and hopefully some Q&A will follow. So what is Sharpcap? Well, Sharpcap is image capture software for images and videos. It's been around for about 10 years now. It's started in 2010. And the author seems to be a very nice fellow by the name of Robin Glover, and he's running his own website over in the UK, sharpcap.co.uk. And the software is developed over a fair bit of time, but it initially focused on sort of high frame rate image capture, or in other words, lucky imaging or planetary, what we would think of as planetary imaging. The software is developed over time. So on his own website, he talks a little bit about the history here, and I was interested because he was talking about his frustrations with AMCAP. I'm sure a few of us remember AMCAP. So when video cameras were first coming out and first being applied for astronomical imaging and taking pictures of planetary targets, and then using things like Registack to sharpen them up and bring them up, AMCAP was sort of like your very, very basic software that could be used to work with things. And he talks about some of the problems here, and because he was a software developer, naturally his solution is not to complain. His solution is to actually go and build one himself. And so that's what he's done, and that's where Sharpcap has come from. Now, I noticed here that he got a link from Basler Cameras. Never heard of Basler Cameras, but Basler Cameras asked him would he support their cameras. So it was a bit of a partnership with a software camera company that sort of got him into the business and got him developing this particular imaging software. So currently, there is a reasonable selection of cameras that are supported here. And you can see that most of these cameras are what I would call high frame rate cameras, like cameras that are designed to take more video type pictures rather than long exposure cameras like, say, an S-Big or something like that. But it doesn't mean that these cameras aren't also capable of taking long exposures. So in its present form, Sharpcap can do a very, very credible job of working with video type imaging, whereas but you can also take like a 30-second or a 2-minute exposure as long as the camera supports it. So that's a fairly broad range of cameras that's there. So why did I end up using Sharpcap? Well, for those of you that remember my earlier presentation about the QHY-174 GPS camera, it's the only imaging product out there in the market that works with the QHY-174M. So, back to the thing, he has a partnership with QHY where he is actively working on adjusting his software in order to work with the API and the toolkit that comes to the camera. And that camera is the only one in the market that has the ability to embed a GPS timestamp on the frame, and because the camera uses USB 3 technology and the fast throughput available on both the camera and the USB 3 connection, you're able to take video, astronomical video, and convert it directly to digital. And then when you add that GPS timestamp, you've got what you need for occultation astronomy, where that timestamp plus sensitivity and time resolution is very important. Why am I interested in occultations? That's a whole other presentation. but essentially that's citizen science, where you have a rock in space that occults a star is seen from Earth. And if you have enough observers participating, they can time when the star disappears and when the star reappears. And using that information, you can get pretty precise information about the size and the shape of the asteroid. And then that information combined with the brightness and the spectrum of the asteroid tells us a lot about what it's made of and its albedo, and whether it's a fresh chunk that's broken off of an asteroid 1 million years ago, or it's a primordial chunk that's been around since the beginning of the solar system. So there's a lot of potential science that can be done through occultations, and the baseline sizes, the accurate sizes for some very small asteroids that we're able to provide through occultation astronomy is a very, very useful part of the overall picture of understanding the outer parts of the solar system. These days, a lot of emphasis on trans-Neptunian objects, as well as even comet occultations, are all part of the discipline here. It's one of those interesting side disciplines for astronomy. So next I'm going to take you to put together is essentially trying to allow me to do occultations from my home when I need to. I have a lightweight Vixen Great Polaris mount with SynScan and EQ mod running it from a go-to perspective. My primary instrument's an 8-inch Schmidt-Cassegrain with a fast star adapter, which takes it from 2,000 millimeter focal length down to 432. So essentially turns it into a pretty wide field scope. The aforementioned camera, I use the Sky X and Sharpcap and then Occult Watcher software to identify targets and figure out what targets that are useful and ones that I can reach with my rig from Toronto. So I mentioned my challenge, and this is my challenge for my preferred observing location. As you can see, Polaris is not directly visible at the moment, and short of yeah, sorry. Okay, where did it stop? Where did it stop, Andrew? Okay. Okay, thank you.